Hello everyone, welcome to the channel Simple Concepts by DJ. Today we are going to see a numerical problem that is based on nodal analysis. Nodal analysis containing three different sources. Okay, so let's get started. Here, this is the circuit diagram that we need to consider for calculation purpose. The question is, we need to find the value of current that is flowing through this 3 ohm resistor. Okay, the value of the current that is flowing through the 3 ohm resistor by using the method of nodal analysis. Okay, so what is the value of the current that is flowing through the 3 ohm resistance using nodal analysis method is the question that is being given to us. So with the circuit diagram under consideration, we need to work it out. Okay, and find the value of the current. So first thing is, the step is, once the circuit diagram is given, we need to mark the direction of currents. Okay, so this is a battery source, this is a battery source, and this is a battery. Okay, so now when the switch is closed, a current will flow from the positive terminal of the battery. Okay, let us assume that this point is node A. Let us assume this point is node A, and the voltage that is developed in this point A is represented as VA. Okay, so now what happens is a current I1, let us assume the current that is passing through the 3 ohm resistor be I1. Okay, so this is the value of current that we need to find, okay, using the method of nodal analysis. So this current I1 flows over here. Similarly, from this 4-volt battery, another current which we are going to name as I2 will flow. I2. So I1 and I2 will flow and they will meet at this point, that is at node A, and they will combine to form a single current that is called as I3. So in this circuit diagram, we have three different currents have been marked. One is I1, one is I2, and another one is I3. So now what we need to do is, the step one, we need to find the current I1 that is flowing through this particular resistor. So before starting that, what we need to do is, in this node A, we need to apply the current law, KCL. So applying KCL at node A. So I'm going to write this as node A. Node A. So I'm going to apply KCL. So the incoming current will be taken as positive and the outgoing current will be taken as negative. So in this part, we have two incoming currents and one outgoing current. So considering all the incoming currents to be positive and the outgoing current to be negative, what I'm going to do is I1 plus I2 minus I3. So it will become I1 plus I2 minus I3 equal to 0. Okay, let us assume that this is equation number 1. I1 plus I2 minus I3 equal to 0. Let it be equation number 1. Okay. So now I had framed this equation. Now I want to find the value of individual currents. So for finding the value of current I1 will be, see, this is 4 ohms, this is 4 volts, and this is the voltage that is being developed at the node A. So I have 4 volt, I have the voltage VA, as well as this 2-volt source. So these are the voltages that I need to take into consideration, because I'm going to find the value of I1. I1 is a current which flows from here to here. Okay, so I1 will be 4 minus VA, the difference in voltage. So 4 minus VA, which is 4 minus VA, and since the current moves from the positive terminal to from the negative terminal to the positive terminal of the 2-volt battery, I am taking this voltage value as plus 2. So it will be plus 2 divided by the resistors. How many resistors have been connected in this branch? So we have two resistors that has been connected in branch in series fashion. So when resistors are connected in series, we need to add the resistors. So if I add the resistor, 3 plus 2 will be 5. So that is 5. So this is the value. So 4 plus 2 is 6 minus VA divided by 5. This 5. This is 5. Okay. 5. I1 is equal to 6 minus VA divided by 5. Similarly, the value of I2. I2 is nothing but the difference in potential in this branch. I2 means difference in potential, that is 4 minus VA. I2 will be equal to 4 minus VA divided by the resistor that has been put in this branch. So the value of the resistor is 2 ohms. So divided by 2. So this is the value of I2. Similarly, what is the value of I3? To find the value of I3, I need to take this branch, the length of this branch from this point A to this. This is the reference node. Let us assume as a D. D is called as a datum or reference node. From A to D, I need to consider this branch. In this branch, I have one voltage that has been developed, and I have one resistor value and one current I3 which is flowing. So according to Ohm's law, I3 will be VA divided by the resistor that has been put in this branch. So I3 will be I3 will be VA, which is VA divided by R is 2. So I have got the value of I1, I got the value of I2, I got the value of I3. So using this, I'm going to substitute in this main equation. So if I substitute means it will become I1. I1 is 6 minus VA divided by 5 plus I2. I2 is plus 4 minus VA divided by 2 minus I3. Minus I3 is VA divided by 2 minus I3 VA divided by 2 equal to 0. So now what I'm going to do is 6 divided by 5 minus VA divided by 5 plus 2 minus VA divided by 2 minus VA divided by 2 equal to 0. Now taking this terms, 6 by 5 plus 2 and minus VA is taken common outside the bracket. So it will be 1 divided by 5 plus half plus half. That will be equal to 0. So 6 by 5 plus 2. What is 6 by 5 plus 2? 6 divided by 5 plus 2. 5 ones are 5. 6 plus 10, which is 16 divided by 5. So 16 divided by 5 minus a VA into half plus half is 1. So 1 by 5 plus 1. 1 by 5 plus 1 will be 5 ones are 5. 5 cancel, 1 plus 5, which will be equal to 6 divided by 5. So VA into 6 divided by 5 equal to 0. So minus VA into 6 by 5. 6 by 5 equal to minus 16 divided by 5. So 5 gets cancelled. Negative will get cancelled. So we'll be left out with 6 into VA. 6 into VA equal to 16. 6 into VA equal to 60. 6 into VA equal to 16. Therefore, which implies VA will be equal to 16 divided by 6. 16 divided by 6. 2 3s are 6, 2 8s are 16. Therefore, VA equal to 8 divided by 3 volts. So the value of VA is nothing but the voltage that has been developed in this node A is nothing but 8 divided by 3 volts. Right. So now we have found the VA. We have found VA. So we need to find the value of the current that is flowing through this 3 ohm resistor. So what is I1 actually? I1 is, we have this formula, I1 equal to 6 minus VA. 6 minus VA divided by 5. Divided by 5. So I1 will be equal to 6 minus, what is VA? VA is 8 divided by 3. So 8 divided by 3 divided by 5. So which is equal to 6 by 1 minus 8 divided by 3 will be 3, 3, 3, 18 minus 8. So which is nothing but 10 divided by 3. So I'll be getting 10 divided by 3 divided by 5. So which is nothing but 10 divided by 3 into 1 by 5. So 5 ones are 5, 5 twos are 10, which is nothing but 2 divided by 3. Therefore I1 I1 will be 2 divided by 3 amperes. I1, the current that is flowing through the 3 ohm resistor, is nothing but 2 divided by 3 ampere. So this is the answer for this question, right? Thank you guys for watching this video. I hope this video would be very interesting and informative to you. Please do subscribe. Thank you all.